A curve has this equation and a line has this equation where k is a constant. Show that the x-coordinate of any point of intersection of the curve and the line satisfies this equation here. The curve and the line intersect at two distinct points. Show that this inequality holds. And find the possible values of k. Right, here's the question paraphrased then. So where do they meet? Well, part A. So here they're going to meet if the y values are the same. So 2x squared minus x minus 1 needs to equal k times 2x minus 3, which is equal to 2kx minus 3k when we expand the bracket. 2kx minus 3k. So that tells us then that 2x squared minus x minus 1. Move this over minus 2kx and move this over to plus 3k equals 0. So we move this over and flip the sign. We move this through the equals and flip the sign. So that tells us then that 2x squared. Now we've got a minus x and a minus 2k. So we can put the minus outside a bracket and we'll have the 2k plus 1 then together. Lots of x, that's those two. And then we've got plus a 3k here and a minus 1 here. So that's what we wanted to show then. Now these meet at two distinct points. So for that to be the case, the discriminant is positive. So b here, b squared needs to be greater. B squared is this, 2k plus 1. The minus squared will be a plus, so it's just that squared, is greater than 4 times a, which is 2, times the c, more than one term, put a bracket. So we end up with 4k squared then. On this side, plus the 4k when we expand the bracket, plus 1, is greater than 8 3s are 24. Okay. 8 times minus 1 is minus 8. So that tells us then 4k squared. Move this 24 through to minus 24. 4 take 24 is minus 20. And then 1 plus 8 now, because move that through, becomes plus 8, is 9. So that needs to be greater than 0, which is what we wanted to show. Find the range of k values here then. So when is that greater than 0? Okay, let's try and factorize it then. Now, because I've looked at this in 2 2s, 9 2s are 18, and 2 1s are 2, and that makes 20, so I reckon it's 2k and 2k, with a 9 and a 1, and a minus is greater than 0. 4k squared? Yep. Minus 18 minus 2 is minus 20, and a minus times minus is a plus. 9 1s are 9, so that's fine. It's a positive quadratic, so if you were sketching it, the roots would be at k equals a half here, and k equals 9 over 2 or 4.5. 9 over 2, and it's positive k squared, so it's a U-shaped curve coming through these two root values. So we're basically asking, when is this quadratic curve above the x-axis here, or the k-axis? Okay, when is that above the axis? Well, that would be above when k is bigger than 9 over 2, or when k is less than 1/2. So there's our range of solutions for k.